Good evening, ladies and gentlemen. We welcome you all to Digitalati's full stack series, FB Live. I would be taking a check on my teammate, Ms. Priya, once in a while to see if I am audible. Ms. Priya, do I have a heads up? Am I audible? Is it clear? Right. This means that it is fine. I welcome you all to this live series, and to start with today we will start with this full stack, and in full stack web series we are going to talk about the important features with Java 8. So Java 8 features, technically, there are a lot of features. There are a whole bunch of new features that have come with this Java 8, and out of which we are going to focus on one or two important features that we would be able to cover within this short span of time. And this is going to be a series, so we have more live shows to come. So what we wouldn't be able to cover today would be coming up with yet another live show of ours. Always when I talk, people ask me this question: what do you mean by an IT finishing school? We are India's first IT finishing school, and when we say we are India's first IT finishing school, it's not a novel idea. While India is known for a finishing school long ago from the epic of Ramayana. In the epic of Ramayana, we have heard that the sons of Dasharatha, Rama, Lakshmana, Bharata, Shatrugna, learned the best of these skills from their guru. Yes, from their Kulaguru. They are the sons of Dasharatha. He is an emperor, so they would have had the best of education. In spite of that, one fine day, this old man Vishwamitra walks into the palace and asks Dasharatha to send the two sons along with him. He took them out and he gave them coaching. Actually, he taught them new techniques of the warfare. He put them right on the field to fight with a demon, to find for themselves which of the arrows that they would use, and also shown them the victorious path to walk through the forest. That's the first finishing school that world had ever known. So what do we understand from that? Whatever you learn at an academic institution, your school, your college, your university, is basically in terms of theory, and you need somebody to put you into a practical field, and that's what we do at Digitalati, India's first IT finishing school. And I welcome you all to walk along with me to explore the new features with Java 8. This is one of our favorite stories, so let me start with that. Speed of change, yes, it has taken years and years, yes, eras over to for this evolution of mankind to happen. And as we all know, it took 5 millennia for the oral information to be converted into a printed text. Yes, it has taken such a long time until that period. Whatever information that we have in terms of scripture or in terms of stories or epics or Puranas have always been passed via oral communication. And it took 5 centuries for this text to be converted into audio, right? Yeah, 5 centuries for text to be converted into audio, and 5 decades for the audio to be converted to a video, and 5 years only for the asynchronous media. You do it at whatever time you want. I will look into at whatever leisure time I have. Yes, that's the way of life today, and all it needed was 5 months for the social networking to become popular. But today, we do not even know the speed at which a technology comes in and the speed at which people implement it. Unless and otherwise, we are actually geeks and nerds. We won't even be able to tap and look into what is happening to keep ourselves updated, abreast with what is happening in the technology field. Every day there is an innovation that's happening, and with this open source and more community contributing towards technology development, so many changes are happening. Why am I talking about this? In fact, the thing that has brought me into the subject is 40 years ago, when we moved from the structured programming language to the object-oriented programming language, there was a huge hue and cry that, oh my God, everything is gone, the adaptation is going to be difficult, so for whatever I have done is fine, why would I have to learn something new? Similarly, 30 years ago, when there was this internet boom and we had to do everything for internet, the internet programming, the scripting, all those things came into picture. Again, there was this everyone would lose the job. I don't know why, when we are comfortable with this desktop programming, why would we have to go for this internet programming, and so many discussions that were on with that. But today, if you look at this, when there is a technology change, we even don't know and we slowly adapt to it. That's the speed at which it is changing. And the most important change that Java 8 has brought within it to us is this one, that the approach has completely changed. That is, from object-oriented programming language, we are going into what is called as a functional programming language. It is a paradigm shift. It's a complete shift that we are focusing on, right? So that means, is object-oriented programming dead? It's perished and we don't need it anymore? No, not at all. We still will continue to have object-oriented programming language, but there are places in which we are going to use functional programming. Until this moment, I have not walked into to say what is functional programming. I'm just focusing on the most important new feature that Java 8 has brought in. So it's just like a change it's a paradigm shift. It's a change in the thought process. It's a change in the way in which we write code. It's the same old object-oriented application, but we are going to do it in a very different way. That's what we will be doing here with this functional programming. So what are the new features? New features, I've just brought in a few top new features listed here. There are quite a good number of new features that Java 8 has brought in, the most important being this functional programming change that has come up with it. So we have something called Lambda Expressions, default methods, snapshot JavaScript engine itself. And there are so many other things with the API, because no application can today stand alone. It has to have some integration. We need to have so many APIs integrated into it, starting from the Google, you use location or payment gateway, or you have this text-to-speech and speech-to-text conversion. So many things like that. We don't, it's not home-proven anymore. We use the ready-made things, so that means we need to do this integration. So all those supports and parallel operation. So it's a change from the multi-threading program towards parallel, because even a simple laptop, mobile phones today, we talk about multi-core. That means we need to know how to write a program to make this multiple cores work for us, and that's where we need to go for this parallel programming. And all those are the topmost features that have come in along with this Java 8. Having said that, we are going to make a pick and talk about a few things here, because with a given short span of time, that's what we will be able to do. Let's try and understand lambdas, and let's try to use lambdas, functional interface, method reference, collections and default methods are what we are going to work on today. So what is this lambda expression? Not wavelength, okay, we are right here in our programming thing. A lambda expression is basically an anonymous function. So anonymous means anamika, no name. So without a name, we are going to deal with something, and if there is no name, where is it going to be? Of course, we are still going to have our class and an object inside which it is going to be there. It is not going to be like a separate entity. It is not going to be labeled. It will not be as an independent component. It is going to be there, but there is not going to be any name. Okay, so it's a part of this Lisp programming language, that is listed programming language, where the focus is on the action. At Digitarati, we always say that learning is a verb. It shouldn't be a noun, right? When we learn something, it is action-oriented. It shouldn't be a noun where you collect, you just, talk about the collection of items and things like that. So, what Lambda expression basically brings to the table is we don't think about nouns anymore, and we talk and work with verbs. Yeah, I will come into detail to talk to you about this. So these lambdas are the ones that are going to enable us to do functional programming. Functional programming, a simple thing that is the most important feature, let me tell you, is it's going to reduce the number of lines of code that we write. Obviously, any team lead, technical lead would be happy if you reduce the lines of code. Yes, so that's the reason that it's the most important, most wanted feature in the development segment. And easy to use APIs and libraries. So there are so many of those that have come along with this Java 8 as a package that we can very easily incorporate various APIs and the parallel processing. So now to understand where is the shift happening, let's go to our favorite territory. Our favorite territory is this object-oriented programming, which all of us know. So what is the foundation of an object-oriented programming? We have a class, we have an object, and we have some actions that we associate with a class and the object. So what do we call classes? Always we tend to say classes are template. It is something that has got a bunch of features, properties, and behavior. An object is an individual, a representative of a class, so it's a copy of a class, and it has all the properties and features of the class, and it has its own values, and it performs the action in its own way, right? So, and then we associate the class and the object by the various features of instantiation, by having inheritance, by doing encapsulation and other things. We do create this. Yes, that remains the same. Now, when we write this kind of a program, what do we focus on? We focus on things. If you see the definition of the object-oriented programming itself, we would always like to say that there are so many things that are there in the real-time scenario, and we try to incorporate all these things into our program. And what is a class? Class, I always call it as a collective noun. Yeah, the class is something that has got common properties and a behavior, common features. So in English, what is this common feature? We call them as collective noun, a pack of cards, a pack of wolf, a herd of elephant, right? So it's a noun, but what is the program for? We are finding a solution. What is a solution? It is basically manipulation of some information, producing some result, looking forward to an action, converting certain things into an action-oriented thing. So it should be a verb. So from the object-oriented approach, noun, we are going to jump into verbs. The programs or the collection, we are going to make them into action, doable things. So it would be easier for me to take you via interface. We all know interface, right? So the biggest advantage of interface is that we could declare some methods, and the implementing class, whichever class implements it, will have its body or a definition or the implementation techniques. Where do we go for interface? The most important key that we talk about when we say we are going to go for interface is that I have a common activity which takes place differently under different scenario. We go for what is called as an interface. Say for example, interface is where I just do the declaration. I love politics, so I would love to quote an example from politics. Interface is, you can take it like an election manifesto. So you make a declaration, in case I win the election, I comment for this change in the education policy, new education policy. So that's the interface. Now, I don't have to define what I am going to do in the new education policy. How am I going to implement? All these are not my headache when I declare. When I implement it, there is this 3-language policy. Now, Karnataka is ready to implement this 3-language education Tamil Nadu is not ready. So this class need not implement that interface. Karnataka will implement, Maharashtra will implement, Bihar will implement. So something like that. So we make in an interface, we do the declaration. Whichever class is implementing it will define the method. So that was a light-hearted joke. Now it's time for me to show you how this lambda expression works. So to help us do this, I've already kept my Eclipse open. I will request Priya to send me a message that my screens are flashing. Okay, I just need a cross check for that. Please do post it whether you are able to see my screen. Thanks. Now let me come here to our program. I do have a simple class here. I call my class a greeting class, and I have a main method here. Supposing I want to say a greetings message, how will I say a greetings message? Probably I will write a program here. Say I have a method, public void greet is my method, and in this method I would go ahead for my I will just say a greetings message. So I welcome you all to this program. Welcome to Digitarati's live series. Okay, so this is what I'm writing. So normally in a program, how do we go about this? We will create an object. So to save time, let me just start it void. So obviously I will go here and call this greet method. Right, I'll call the greet method to implement it here. So let me just go run this. I'm able to execute this program. Now what is important is I want to, each time when I greet, I'm going to greet differently. Have a great evening because you've come in the evening session. If I do a morning session, I'm going to say something else. So every session I'm going to have a different message. Then what would I do? I would obviously go for what is called as an interface, and in each of the class I will implement it in a different way. So let me just go for an interface here. So I'm going to call this interface as greetable. I will follow this naming conventions. All my interfaces will have this doable, greetable, sayable, something like this. So in this, I will declare a method public void greet, and this is here. Now let's assume I go to this class and I want to implement that. So I'm going to remove this off, so I don't want it anymore here. So this class is implementing that interface. So I'll say implements greetable. So when I say that, obviously the thing is that I have to define the body for it. So how will I define the body of? The same name as that of the interface method, I have to give it here. So it is public void greet. I will have it here, and I have to define this one. So let me just go here, and I will say some message here. So this is going to be the message. So trying to explore lambda expressions. So this is my message that I would want to have it here. Now this will run, and I can go create an object and invoke it. You all know this is perfect. So this is the interface. Now I'm going to convert this into a lambda expression. So join me when I convert this into a lambda expression. How am I going to do this here? So I will just bring that here. Now the whole thing, I'm going to convert it into a lambda expression. So what am I going to do? I'm going to say here, I'm going to use my interface's name. Greetable, I have an extra R here, so fine. Okay, so I'm going to say greetable, some name G. Oops, sorry. Okay, is equal to, supposing if I assign a method to a variable, is it possible to assign a method? And that's what we are going to do with lambda expression. How are we going to do it? Now I have this is my interface, you know the name of my interface. I'm referring it here and creating a variable of the type here. Now if you look at this, why do we use an access specifier? Because from an external source we try to access it. That means that we need to know how to access it. What is the right? Do I have enough permission to access? That's why I just go about giving this access. Now that the definition is right here, there is no need for me to say what is the access right? It could directly be understood that I have the permission. So this part becomes useless. So I remove it. Now the statement is right here. So my program on its own can evaluate what is the return type, or whether there is a return type or not could be evaluated then and there directly right in here. Isn't it or not? Right? So in that case, there is no need for me to go for this void because it could read and evaluate. I also remove that. Now the next thing here is, what do I need a name? Always we talk about name because we need a name for us to call. You're going to have it right here, meaning we don't need any place to implement it. It is right here. Then the name also becomes insignificant. So I remove the name. Now all what I need to do is it goes to, so I use an arrow mark to say that greetable G method goes to this one, and this means I just and I can just bring that here code and I will terminate it here. Okay, so this portion of it now becomes irrelevant. So let me remove it. It's in my class. Right away in my class, I'm creating an object for this greetable G. So this is our method, and this is the interface, name of the interface is this one, and this is the method. And I come here and I have this one, and I am going to have it right in here, declared like this. So what do we mean by this? We don't need a name, we don't need any explanation, and we can very simply, straightforward, by creating an object of this type, we would be able to access it. Now it's so simple, I don't even have to go forward to do anything right in here, and there is a termination at the end. Okay, so let me just do this. I'm very sorry, I have a difficulty in looking into the screen. Right, so the equal to wasn't visible to me. Right, so the greetable G, and it implies this one. So as simple as that, I would be able to do it. Now this line also becomes irrelevant, which we wrote earlier for the earlier sequence of activity is also irrelevant. Now what we have done is we've got it here, right here. So now if I want the statement to be printed, all I need to do is print G, call G and print it, and it will print this statement right away here. Now just go forward to check how this prints in here. Okay, so let me just run the program here. have to call g dot greet. Okay, so now I've called this g dot greet and it will execute in here. I'm facing a small difficulty here. Am I connected? Okay, so I was waiting for the heads up. I'm connected and I'm visible, and let's go forward. Right, so this is where we were at. So now if you look at this is our interface. Interface is greetable, and we have a method greet. When we implement the Lambda expression, there is no need for us to mention the name, as we call it right here, and there is no need for us to have the return type, there is no need for us to have the access specifier, and we would be able to access it then and there. Alright, so let me just call it here, and I will be able to get it. So what are we achieving by this? Whenever we do this interface implementation, in your interface declaration also you mention about the access specifier, you mention about the return type, you mention about the name of the method, the parameters and everything, and every time you do a definition, you do an implementation, you can talk about that. That could be avoided by directly implementing this one. And what is the key here? In your interface, this would be the only method that you have. That is the only key that we need. We have to remember while we implement it. Now let me go forward to show you one more thing. This is even more simple. I don't even have to have multiple lines, because this is a single line of execution. As it is a single line of execution, I can finish this then and there by the direct line itself. So only when you have your multi-line, you need a body of the statement to execute. As long as it's a straightforward simple execution, you don't need a body at all, you can right away execute it. So it is very simple. Now to take this forward, what I'm going to do is I'm going to have an interface which takes two arguments, and that would help us to understand how this thing Lambda expression works here. To do that, let me just create an interface. Let me call this as an addable interface. Basically, I'm going to do an addition arithmetic activity. So all I'm going to have is a public void add, and later we can come to the return type. First, let's just see the parameters. So I'm going to have int num1 and int num2 are the two arguments that I'm going to pass on to this one. So this is my interface. So I have an interface, and in my interface I have these declared, right? Okay. So let me have this interface declared here. So my name of my interface is addable, and I'm just going to have this add method here, and let me go ahead and invoke this one. Okay, so let me now implement it here. Now coming to the implementation part, I'm not now going to do implements and take back. I'm just going to go here and do it. So let me have an object for this addable, and I'm going to call this add1. And so what is this? I'm going to have this method, and to call the method, all I need is the parenthesis, and I don't need anything else. And I have to have implies. What does this imply? Let me go for my program. So here I'm going to have two variables into it. Maybe for convenience sake, I will just write the program in our traditional way and also come back. Okay, so if that would add clarity, public void add of. The traditional way of implementation, this is what we will do: int num1 comma int num2 will be the ones, and then we would go for the body and say I have we will definitely have num1 and num2. So let's just say sysout will be num1 plus num2. Okay, so this is going to be the statement. Now, when I convert this, how do I convert? One thing we have learned is we are going to say this is going to lead to this one. We don't need the access specifier public. We don't need the keyword void because it will look into it and it will understand. We don't need the name add because it's going to be invoked right here and know the place of invocation, so we can leave it as such. So we need the two arguments, so it is important for us to pass on that, and we need to know what is the sequence of action that we are going to perform, so that should be there. Now, how will I get to know what is, and this is where it is terminated. Now, how will I know what is happening here? I will just say add1 dot add off, and we need to pass on the two numbers that we need to add, and the activity is completed. It is as simple as that we will be able to do this one. So it is getting us. Now, how much more can I simplify this? As there are no other fancy statements, it's a single statement. I don't have to have any extra things, and I can make it as a single line of implementation. So it is converted into an action. Instead of redefining every time, I can just convert it into a simple action, and the action is completed. Now let's go forward one step ahead, and suppose if this add method is int add, how will this one work? Now I have a return type, right? So how will this work if this is an int add? So in this case, it's going to return some value. So normally, if I have a return statement, what will I do? I will just say return off, right? So in that case, I would just go ahead here and say return off num1 plus num2. Right? So this is how I would be doing this one. I will just say I am going here, and when I have this keyword return, I need to put this in a body inside a frame, because it is implying, it means that there is an activity here. And as it is returning, I haven't stored, either I should have an integer variable and store it here, or I should envelop this with a system.out.println statement so that it prints the sequence of activity here. Alright, so let me just run this one. Okay, it goes on. It's very simple. Now, is there a way, can I make it further simple? Can I make this even more simpler than what we are looking at it at the moment? Yes, we could. What will happen if I don't have a return statement? So I'm just going to go ahead and remove the return statement. I've removed the return statement, and now you can look at my program and how is it working, right? So let me just go and run, and it is working. So if it is just a simple straightforward statement, I don't even have to mention return because my program is going to read into it. You have already given a structure that it is going to return a value. It can look into it and get that value. We don't even have to have an explicit return keyword to do this activity. So it becomes very simple in such ways. So if you look at this with Java 8, you would see that in many places, particularly when you work on threads, you would have seen that you will have to implement that runnable interface. Now you don't have to have a big line, just runnable in a single line, and we will be able to go ahead and work on with it. Now one simple thing with this, so Lambda expression basically is what? It's converting the object-oriented program into a functional in line of representation. It is focusing on the action rather than looking into your declarative statements and how do you invoke. It just focuses because in each of the class, each of the place where you are implementing, you're going to have a different sequence in which you're going to implement. It makes it very simple for your implementation. This is as simple as that about the Lambda expression. Alright, now let me just walk you through the next thing that I have in my mind, the forEach loop. All of us know this forEach loop, which is a very simple thing, and this we've been traditionally using the for loop. From the for loop, we moved on into what is called as this enhanced for loop, and we have a lot more, a simpler thing that has come up here. So let me just go have an import statement. I'm going to have okay, so I'm going to create a collection object and use this for each loop. A very simple thing is what I'm going to do now. Let me just focus on this. Let me have a list. Let me have a list string, and I'm going to say it's li equal to array list. Okay. So just add a list of things. Okay, this month has been a month of celebration. So let me just put a few things. It started off with, so let me put a list of functions that came through our way. We had this Varalakshmi, and then, okay, so then we had Gokulashtami, right, and we also had our Independence Day, so let me add that. And coming up is a very important day, so let me add that too. So it's a lengthy name, so I'm just going to call it as chocolate. Okay, Ganesh allows it. So now, you all know the traditional way. We would have to create a loop, and that should call the object and retrieve it and display it. Now, how are we going to do it with Java 8? So all I need to do is call this list object. I call it li, and what am I going to do here? I'm going to get, you can see here I have this for each, so I'm going to use this for each that you see here. So that's the thing that I'm going to use. Yes, and you just need to, can you look at this? It says you're going to use the action. You're not going to focus on the detail of what object, how referencing and all that. Just mention what is your action. Let me take our own traditional way of doing it. What is our action? The plan of action that we would want to have here in this place is that we would want this, we want this, getting it. So our idea is we would want to have a print of all these ones. Okay, I'm just doing a beat around the bush, so I have to write it all the way. So I want to print this one. What do I want to print? The items that are there in my collection. So that's what I would want to print. So let me just keep it like this. Now, where is it? Let me assume that. What does my for each do is it goes and retrieves the data from the collection and brings it into an item. Let me assume that it puts all the value in the letter S, and what I would want to do is I say it means I would want you to go and print my S. Does it make it very simple? So I just pull the list. Always what we would do is we will create an object, we will say from the list, get this, for each item, iterated and all that. Now I have to do it very simply, get my list, for all the items, for each item in the list, retrieve that value, put it in a variable, whatever it is, and just go ahead and get it printed. So now let me just try to print my items. You can see all those are coming up, and it is as simple and easy as that we would be able to do it. So this is in key about this lambda expression, and we've also seen how we could use this with our forEach loop. Now going forward, I would like to walk you through method references. The method references is yet another important feature with Java 8. We can make a method reference to a static method, we can make a method reference to an instance method, and also to a constructor. To start with, let me start with a very simple way of doing it. Let me have a simple method reference. So it's always easier to have an interface declared and start off from that. So let me go to an interface, and this time it is a reference or referable is what I'm going to have here. Okay, and in that I'm going to have this void ref me. Okay, so ref me is going to be my method. Okay, so done. Now let me come to this class where I am going to implement it. So where we are going to have this. Now what are we going to do is inside the class we will have to have an implementation and then do this. Now basically what happens is when I talk about this lambda expression, people think that if it is going to be a straightforward declaration, how can I go for a reusable piece? So reusable piece of an interface, I have to have, I go for this concept called method reference. Now let me do this method reference. Now I'm going to say I'm going to have a public void, and we call it as, we named it as ref me. I'm going to say it is ref me. And what am I going to have? I'm going to have something. So this is where I will say we are going to have I'm trying to do a static method reference is what I'm going to do. Now how will I do this? So now if you look at this, I would always, when I do this method reference, it's a static method, I'll go first call my, I haven't done this, use the keyword implements. In a traditional class, I would have had this keyword implements to do it. I haven't. So now I have to have a link to my interface that I have declared here, the referable one. So I just go ahead here to create a reference to that. So referable, I'm creating an object, referable REFE is equal to, I'm going to call my current class. The current class is greeting, and in greeting I have what is called as this method ref me method is what I'm going to pass on here. Okay, so now what do? I say once I pass on this, all I need to do is say my current object I have to call the method. Okay, I'll just make a small change here so that I bring the actual referring me. I'll name this as the referring me so that I can call it here. Just to bring a small little change here. So here. So now that has been mapped here. Now under this scope, I will be able to call my method. Okay. So simple as that, I will be able to do this method reference. So in places where you have an interface, and you have a method there and you want to reuse it, we can go for the concept of method reference. So this is what we do under this method reference, and it is as simple as that for us to do it here. So we've done a static method reference. So I told you we could have a static method reference or an instance method reference. What will happen when you have an instance method? If it is an instance method, you will have to create an object for your class and then you have to pass it on to your method. So let me just create an instance reference. Now let's just modify the keyword here. Supposing I don't have the keyword static here. How does this work? Okay, so I don't have the keyword static. In that case, first I need to create an object for the class. Now look at this, our current class is greeting. So let me create an object for the greeting class. I call this as obj is equal to new greeting of. Okay, and now when I want to call this, I will just have to say, with the scope of the object, I will have to call it. So now when I use it here, I will say obj and the reference is like this. So you can have a static method, you can have a instance method. So can you do also with your constructor. Before constructor, I will just show you a very simple example, which is a very popular thing that we use, what is called as a function, by function. So let me just try to do a simple by function here. So to do this by function, I'm just keeping an eye on the clock. I have a few more minutes to go about with this. So let me just do it here. And also I will walk with one more example of a default method, and with that I would be able to talk about the most important features here. So let me call this class as added method. And have this here. Okay, that's going to be my class. Here, let me also have it another class. This class, I'm going to call it as arithmetic. And in this class, I'm going to have few add methods. I'll just stop with 2 as I'm running out of time. I'm going to say public static int add of int num1 comma int num2. So this would obviously return num1 plus num2. Okay, so let me repeat the same thing. I'm going to have copy paste it so it will sit in here. Right, and this time again, this is going to return a float, as one of my value is going to be float. Okay, now how do I do this method reference here? So I would obviously go here to use. So to do this, I need to import java.util.function. So let me import that. Import java.util.function. Yeah, function dot by functions. Oh, you got it. I wonder. By function. So this is what I'm going to import and use it here. And now to do that, let me just go use this by function. I will talk to you about this by function. So if you look at this by function, the by function has a structure that it takes 3 arguments. So it takes the inputs and it takes the return type, and that's how this works. This makes it very simple way of doing it. So look at this. I'm just going to say I have to pass on these values, right? So the first thing I'm going to say, the first argument here is an integer. The second argument is an integer, and the third argument is an integer either. Okay, so this is my by function, and this I'm going to call it as 81, which is going to be from the arithmetic. I'm going to have a reference to the add method. Okay, so this is where I'm just going to make my reference to. So that's the static method, right? So I'm calling the add method from there. Now let me just say so I'm just getting that in here. Okay, so this reference has been done. Now we would be able to get this value here, and we will be able to invoke it. Now I just call this 81 of, but if you see 81, I wouldn't be able to call it directly because this will not work directly. I have to do it by using 81 dot. You can see here there is an apply. By calling the apply method, in apply I need to pass the arguments, so I'm just passing the arguments, whatever comes through. I'm just doing it and I'm passing it on. In a bit I will also run the other one and show you. So it's so simple. Now we have another function, right, which takes an integer, a float, and returns a float. In that case, how do we do? So it will be like the first value is argument is integer, the second value is float, the third value, that is the return type, is also a float. This is how I have to declare. And I have to say that this is referring to the arithmetic, and there is the add method there, which I am referring here. Now again, if I have to do this, how will I do this? Dot out of println of 82 dot, I call the apply method. You can see here I have this apply which will apply the integer float value, and now we need to pass on these values. Say, let me just say 10 and 10 comma point. Something like this. So this is what I am trying to pass on here, and I will be able to do that. Where did I go? So the float. Okay, so that's the key here. So this is method reference, and we will be able to make a method reference. Now, of all these things, there is another value, that is the default method. Default is very important for us to know because it helps us to do what is called as, you can have a method completely declared in your interface and still access and use it. So to do so, I'll just have a simple interface wherein I will have a method and still access it. To do that, let me just go here and add an interface. So this, let me call it as doable, because it's I'm already going to complete my activity here. So in this interface, I'm going to have a method declaration void to it is what I'm going to call it. And the key thing here is I'm going to have the keyword default, and I'm going to have the complete body explained, defined. Here is it. So the whole thing is being done here. So I'm going to have this method, default method is all what I'm going to call, because I have to go to end. So I've given, and all I need to do is to go to my class, and in my class I'm going to invoke it. As simple as that. In my class I want to invoke it, say so I need to put the keyword static. Okay, so I think you will know this. Now if I have this one here, I'll need to just go to my class, implement, and I will be able to have it invoked here. Now as I'm coming to the tail end of the program, I would just go back to talk about one more point and to see if there are any comments that I would need to answer, because I just have few questions coming in into my device. I'm just checking on that as well. Right. So this, what we have been doing today is we just explored few features of Java 8. The idea, the focus has been to look into the Lambda expressions, and we walked into to understand the paradigm shift in the programming approach, where we're moving away from object-oriented programming to what is called as the functional programming. Why functional programming? Because it makes the number of lines that we write for our program, the coding lines, being reduced. So we prefer to go to this one. Right? We saw Lambda expression, we saw method references, and we saw this default method. Coming to that, Priya, is there any question that you think that I should be answering? Priya, are you there? Do you have any question for me to answer? Right, I'm not able to see any question there. In case you have any question, you can reach out to us. You can even post a comment here. We would come back to you with our answers. Yeah, and if you still have, you can write to us, or you have our contacts here, you can. And with that, we are coming to the end of our live show on Java 8. The most important features of Java 8, the Lambda expression method, references, and the default method. It's a very important festival tomorrow, the Ganesh Chaturthi. The Lord who himself came forward to the request to write Mahabharata for the great sage. So, and as we see, he is an epitome for learning. So let's go to his feet and all continue to learn. And also he is known for removing away hurdles. So let's go to him to remove all the hurdles that we are facing through Corona, and to have a very, very happy life going forward. Here to you. You can connect to us via digitalati.com, or you can write to us at mentor@digitalati.com, or you can also call us or WhatsApp us at 9940623934. I'm looking forward to joining you all in yet another live program. Thank you.